different numbers boards and see if we can look at some patterns. And so students at this point should be able to count to 100 by 1s, 5s, and 10s. So we want them to be able to kind of skip count that way. They should be able to identify some multiplicative relationships. 5 and 15 are related because there are 3 5s in 15, right? So we want to be able to have some of that prior knowledge. We also want them to be able to use ordinal language. Ordinal being like first, second, third kind of relationships. So the positions of numbers, last number, that kind of thing. So those are all things that our students need before we approach this activity. All right, so I've got a lattice of numbers with the row numbers listed and then some data in my rows. All right, so what number is in row 1? 1. Okay. What numbers are in row 3? 1, 2, and 3. Okay. How many numbers are in row 4? 4 numbers. All right. The dots down here just mean that this pattern is going to continue, right? Okay. So what would be the last number in row 6? 6. And how do you know that? So we can start to see here that this row number matches up with the last number or even the number of numbers, right? So we would assume that the last number in row 6 would be 6. Okay. All right. What would be the last number in row 20? 20. And row 60? 60. So we could make a rule there, couldn't we? We could make a rule. And how might we word a rule for that?
The numbers in the rule would equal the row. The number of the row
would equal the number at the end.
Okay.
Or the name of the row.
The number name was
the number of the row would equal
how many numbers.
Okay. Can anyone add to that rule? Or reword that rule or revoice in a new
We
way?
could say, with each row you add 1 more.
Oh, I like that rule. With each row you add 1 more to what?
Number before it.
The number before it. This kind of math talk is what should be happening in our classrooms, right? We should get our students to kind of talk about what kind of rules and how can we add that rule? How can we restate that rule? What's another way? What's another rule we could add to this? We get them talking about that in the classroom. We're beginning the concept of functions. That's what this is. This is the beginning notion of a function and a rule, and being able to make generalizations for any row. What could we state about that row? And that is powerful in the math classroom because that's really critical thinking, making those generalizations, making conjectures. That's a kind of a big push right now to get our students to. The thing that I see at the upper level is that students are so used to following procedures that if they haven't seen that problem before, then they don't even know how to approach it. So I can't give them every example they're ever going to see in their life. I have to get them to make generalizations about what's going on so that in any given scenario, they can apply that generalization to that concept. So when we're teaching students adding and subtracting and doing those things, we need to be teaching them the generalization of that. And so that's kind of where this activity is going. It's kind of thinking about making generalizations and getting students to talk about what are those generalizations. So I've got a new lattice up here. Let's move from this lattice to this lattice. This is a different lattice. What numbers are in row 2? 6, 7, 8, 9, 10. Okay. Would the same rule apply here that we applied here? No, why not?
There's only 5 numbers in the row.
Okay, there's 5 numbers in each row, whereas in this one, what's going on? They're adding each other, right? Okay, good. So we're making comparisons between lattices. Good. How many? We talked about there are 5 numbers in each row. What numbers would be in row 5?
21, 22, 23, 24, and 25.
And how do you know that?
Bring
We're counting.
It's extending.
We're extending, and each of these is counting by 5, which our students should be comfortable with, right? Okay, counting by 5s. Okay, well, could I make a rule about the ending number in each of these rows? Can someone tell me what the rule might be for the ending numbers in these rows?
To multiply 5.
To multiply 5.
Counting the row number times 5.
The row number times 5 to get the answer. Let's just check and make sure that rule works. So row 2, you're saying I multiply 2 times 5, and what is 2 times 5? 10. So what would be the ending row number for row number 6? 30. Well, we can do that very easily, right? 5 times. What might your students do? Would they count by 5s maybe? How many times? They can see them count, right? 10, 15, 20, 25, 30. They get to 6, right? Okay, so we're making generalizations here about a rule that would be applied to this lattice. Okay, so your students could see that relationship, we would hope, right? Okay, so what we're going to do today is, let's just go a little further with this for a second. If I asked you, what would be the first number in row 7? 31. How do we know that? Because you did what?
Row 6 ended in 30. We just did that, and I
Yep.
added 1.
Row 6 ended in 30, and so the next number would be 31. Very good. What about the? So then you could get harder, and you could say, well, what about the 4th number in row 8?
39.
And how do you know that?
Because the 8 row would be 40 minus 1.
So you did 8 times 5, which would be the last number, minus 1. Okay, so here we're really extending our thinking, right? We're really getting our students to apply their fact families, getting them to look at what's the best way to get there without counting, right? We want them to get away.